Hello and good day to all of you. So in this video lecture, actually we are going to learn about the galaxies, and also we will learn more about our galaxy, which is Milky Way. So we have started from the universe, so how the universe was formed, so which has been discussed in the previous lecture. And now we are looking at the galaxies. So prior to start the lecture, so there are actually two learning outcomes for the piece of lecture. So the first learning outcome or the objective of this lecture is to learn what is galaxy and their types, and also learn about the galaxies, which is Milky Way, our galaxy. And the second learning outcome or the objective of this piece of course or piece of lecture is to understand the components and elements of galaxies. What are the components and the elements which actually forms the galaxies? So let's think about what is a galaxy is. So if you look at the Oxford Dictionary and look at the galaxy, so it is stated that a system of millions or billions of stars together with the gas and dust held together by the gravitational attraction. So this combination of stars, planets, asteroid, meteorites, all the elements together with gas and dust. So these are actually making the galaxy. So this was the information or the definition we got it from Oxford. But when we look at the NASA, which is the more authentic research institute or the organization for the astronomy, so we got the definition from NASA. A galaxy is a huge collection of gas, dust, and billions of stars, and their solar system. Obviously, one of the solar system we are belongs to, which is our solar system, but there are also billions of solar system which each and every stars or the galaxies have the solar system. So it's all together with gas, dust, and also the gravitational attraction as well. So a galaxy is held together by gravity, because if there is no gravity, then there is no attraction, and all the elements of the galaxy will be goes away from the center of the gravitational power. So our galaxy, the Milky Way, is also has a supermassive black hole in the middle of its galaxy. So over here you can see, so this is our Milky Way galaxy. So if in this galaxy, if we look where is our solar system, so we are on one of the spiral of this, or the arm of the spiral arm of the galaxy. So the solar system, the whole solar system exists at this point, and this star which appears to be like a static form, so this is actually our sun, and the planet which we are living in is Earth, is over here in a small dot of the part of the solar system. So now we look at the galaxies types. How many types of galaxies we have? So actually there are three types of galaxies. So one of them is a spiral galaxy, which we have looked at before. And actually the galaxy which we belongs to, or our solar system belongs to, is a spiral galaxy, which is the Milky Way. And the second type of galaxy is the elliptical galaxy. So these type of galaxies have looks like this one. And the third type of galaxy is irregular galaxy. So there are millions and billions of galaxies exist in this universe. So our galaxy, which is actually the spiral galaxy. So now looking at the major component of the galaxy. So When we are talking about the components of the galaxies, so there are actually the main component of galaxies are stars. And obviously these components can be divided into different types of component with the related to the age and number of a star. So there are three types of major components of galaxy. So based on the age and number of stars, we have divided into global clusters, and the second one is open cluster, and the third one is stellar association. So why we have divided into three clusters or the to understand more about the galaxy. So we are not talking about the types of galaxy, but the component which is inside the galaxy based on the number of stars and the cluster. So we will be looking at the globular clusters, which actually comes from global shape, or this looks like a global. So we'll look into the details. So let's look at the first type of or the component of galaxy, which is the globular cluster. So the term globular is actually came from global, so it looks like a global type of stars or the clusters which are together with forming the globular cluster. So when you look at the globular structure, it's actually a spherical collections of stars. So you can look at this figure as well. And the globular clusters are very tightly bound by the gravity because the gravity is very high. So with the high concentration of star toward its center. So you can see number of stars are in the centers. But if you look closely this part, so there is a number of stars in the other other than the middle. So that is the globular clusters. And the largest and the massive star clusters are globular clusters, so called because of their roughly spherical appearance. So these are actually the biggest clusters of the galaxy. And the galaxy contain more than 150 globular clusters. If you look at the Milky Way Galaxy, so it contains more than 150 globular clusters. But we suspect there is many more globular clusters in Milky Way, but because of the visibility, because of the wave band, it cannot be appeared. So we have been exploring 150 globular clusters until today. And they are arranged in nearly spherical halo around the Milky Way, with the relative few towards the galactic plane, but a heavy concentration toward the center. So you can see this is a big picture of this globular cluster. So 1, 2, 3, and so on. If you look closely into the globular cluster, so it is actually looks like this one. And the second component of the galaxy is the open cluster. So now we have been dividing the galaxies into different clusters. So the second is a open cluster. So open cluster is a type of star cluster which is made up of few thousand stars that were formed the same giant molecular cloud to have the roughly the same age. So you can look at the figure over here. So if you look at this one, so it's actually the open cluster is smaller than the globular cluster, but it contains thousands of stars. So one of these stars is our sun, but similarly like sun, we have thousands of other stars or the solar system. So it consists of these types of stars. So if you look at the how many open clusters we have found out, so more than 1100 open clusters have been discovered within the Milky Way Galaxy, and there are many more. We thought there is existence of many more open clusters because of the visibility away from the our region, so we can't see that one. So the clusters smaller or less massive than the globular cluster as mentioned, and are found in a plane of galaxy intermixed with the majority of the system's stars, including the sun. And these objects are open clustered, so that it is called, and they are generally more open and loose appearance than the typical globular cluster. So these are not very tightly, so the gravity is not that high for these open clusters. And the third elements of the galaxy is the stellar association. So the stellar association is a very loose star clusters. So even you can look at the names of the stars. So if you look at the nearly star from our sun, so you can still look at, so these called the stellar association. So these are looser than both open cluster and the globular clusters. And the stellar association will normally contain from 10 to hundreds or more stars. So it's not beyond 1000 stars. So even younger than the open cluster and stellar association are very loose grouping of young stars that share the common place and time of origin, but they are not generally tied to closely enough together gravitational to form a stable cluster. So it's mean the gravitational power inside the open cluster or the stellar cluster, stellar association is much more less than the globular cluster. So the stellar association are limited strictly to the plane of the galaxy and appears only in a region of the system where the stars form in occurring, notably in the spiral arm. So if you look at the arms of the galaxy, so it will be appearing on that side. It will not be appearing on the main arms of the galaxy. So now we are looking at the galaxy, which is the Milky Way. So what I'm talking about is the open clusters are normally, they are appears to be here, open cluster and stellar association. But if you look at these dark points, so these probably are the globular clusters are especially in this part, but the open cluster and the stellar associations are on the arm of this cluster. So okay, now we are looking at the size of the Milky Way. So now if you look at the size of Milky Way starting from this top to bottom, which is the diameter of Milky Way is around 125,000 light years in diameter. So how much is 1 light year? Is actually a light year is a distance when the light travel in 1 year. 1 year mean the Earth 1 years. So it is around 6 trillion mile or 9 trillion kilometers. So if you look at, so you can just imagine that your Boeing 747 actually travels from 9, which is the maximum speed, 988 kilometers per hour. So this is per second. So this is the speed of Boeing 747. This is the fastest, I believe, that in the Earth. So if you see the light year is much more bigger than that one. So now where are we? We are actually here. So this is our solar system. So it does not matter it's 125,000. In some places it is written that it is 100,000 light years. So it doesn't matter. I mean, it's still a huge Milky Way galaxy. And how old is our galaxy? Is 13.2 billion years old, and there are 200 to 400 billion stars with at least 100 billion of planets, 500 millions of many support life. So it's a huge world we are living in. So there are three views, I mean, of the Milky Way galaxy. just to come up with the place where we are. So this is actually the Milky Way. So like here I mentioned that in some places you will find out the diameter of the galaxy is Milky Way is 100,000 light years. So it doesn't matter. It still is huge. And when we look at the axis of this galaxy, so if we plot the axis over here, so it's like this one. This is the Earth equator, and this is the plane of the or rotation of the Earth axis. But when we look at here, so from here you can come here to the Earth. So this is a 3 view of Milky Way galaxies, how it looks like. So there is actually some other galaxies which are nearby to us, and obviously there's millions of galaxies in this universe. So we are looking at the nearest galaxy, so which is our neighboring galaxy. So the Andromeda galaxy, or it is also called M31, is the nearest large neighbor of the Milky Way, and thought its side some about 2.5 million light years away. So still it is quite far, 2.5 million light years away, and that makes it most distant object regular visible in the naked eye. So if you look at where we are, so we are actually here. It's a Milky Way, and the Andromeda is here. So it's about 2.5 million light years away from the Milky Way. So this is the nearest one. So how much far the other galaxies? So this is the second galaxy, which is Triangulum Galaxy or M33. And also there is a concept or there is a theory which state that there will be a collision of Andromeda and the Milky Way sometime after the 4 billion year ago. 4 billion year in the future, not ago. So I have a small video. It's actually from the NASA. So I'm going to show how it will be colliding and where we are right now. So if you look at the galaxy, how does it looks like and what is the rotation or revolution of this galaxy? So this video will explain slightly good. So now here we can look at the galaxy, which is our Milky Way. So you can see it's keep moving, and on the below side you can see it is the time which shows is 1.6 billion years ago. It's the future of tool. It's a future time actually. So from now you can see this Andromeda. This is Andromeda is actually coming near, or these two are coming near to each other, and in 4 billion years they will collide with each other. So you can see once they collide each other, then the spirals become behave like differently. Then there will be another collision from 5 to 6 billion, and in 6 billion years in future, so it will be collide together. So that is the theory which shows, and somehow this another galaxy which is near to the Milky Way and Andromeda, it will also be mixed with this collision of galaxies. So hope you have understand about the galaxies and understand and learn about the Milky Way, and how big is our galaxies, what are the components, and also what are the future happening with our galaxy. Okay, with that's all. Thank you so much and hope to see you in the next lecture. Okay, have a good day. Thank you.